Hello, everyone. A very good afternoon. My dear authors and invited guests, welcome to Technical Session 11D. Myself, Sirali Gaur, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communications Technology for Sustainable Development ICT4SD 2026 Goa, India. The 11th edition of this conference is being organized in a hybrid mode. The physical event is being held today, the 11th of July 2026 in Goa, India, and the virtual event is being held through Zoom from 9 to 11th July 2026. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have a total of 10 presentations. Each presenter will be given 10 minutes for their presentation and 2 minutes for question and answers. On the 9-minute mark, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or any update, please write to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session today. Professor Archana Burujwale. Professor Archana is an assistant professor in the Department of Computer Science and Engineering, Artificial Intelligence at Vishwakarma Institute of Technology, Pune, India. With over 13 plus years of academic experience, her research focuses on AI, deep learning, and computer vision with a strong emphasis on practical applications. I welcome you, ma'am, to the session today. And would you like to say a few words before we start with our session today?
Thank you, ma'am. Yes. First of all, thanks to the organizing committee for giving me this opportunity to chair the session. So, good afternoon, everyone. On behalf of the organizing committee, I warmly welcome you to the session of the ICT4SD conference, 11th International Conference. So, it is my privilege to chair this session today. So, thank you. And we can start with the session, I think, Sirali.
Thank you so much, ma'am. So, our first presenter today would be Daramane Kulibale with the paper title A Multi-Agent Systems Based on Prediction Approach of Household Energy Demand in Burkina Faso. Dear presenter, you may start presenting.
Okay, hello, I'm here.
Yes, sir, you may start presenting.
Okay, I'm sharing my screen.
Yes.
Can you see my screen?
Yes, sir.
Okay, I'm starting the presentation.
Trying to understand. Is that enough?
The topic, uh, the topic of the presentation is a multi-agent system based prediction approach for household energy demand in Burkina Faso. The Angela, we have the part one, we have the introduction, the second part, we have the description of model, and finally, we have a conclusion and perspective. Introduction the challenge. With an improvement in living conditions, many electrified households now use household appliances. The use of this new equipment creates new energy need. In 2089, the national access rate was only 25%, but ambitious target aim to reach 50% in rural areas and 95 in urban areas by 2030. What is the problem of the study? The problem is how we assess the impact of urban household energy consumption in each region of the country. The research objective. We have three objectives. The first objective simulate the electric electrical consumption of urban households in regions based on socio-economic and climate scenario. The second objective: identify the regions that consume the most energy in your country. The modeling approach for energy consumption. In terms of this modeling approach, we are analyzing the paper to determine the characteristic of household appliances as the use time, the probability of use during the weekend and of weekday, and to determine the climate variation influence energy consumption. What is the choice of modeling approach? We choose the multi-agent approach because the multi-agent approach is based on organization and interaction between agents. It also offers a possibility of creating a simple of dynamic representation of agent behavior. The second part, the description of model. We use ODD protocol. ODD is meaning overdue design conception description. ODD protocol standardize the use of agent model. It is a current framework for modeling complex model. It makes the description of model understandable. The tool user. The user of the free tool. The first tool, Gamma platform. The Gamma platform we use the Gamma platform for building the model and running the simulation. Excellent for data processing and visual paradigm for model design. The source data. We have four source data. For example, we have a 2019 population and using census, the InfoClimate database, the monograph of Ouagadougou, and 2021 Burkina Faso demographic and IFA survey final report. The hypothesis. We have a three hypotheses for the study. The first hypothesis: a group of households belongs to household type determine whether one certain equipment. The use of equipment by the household is based on probability of use. The probability of equipment used by the household depends on the time of day of the week. A group of households is represented by an agent characterized by a certain household size. For the initial scenario of the simulation, we define an initial group household for each region. We design concepts. Here we have the entity of model. For example, we have a group household contain a several household. The household use several equipment. The type of equipment. We have a free equipment of the study. For example, we have the fan. The fan is characterized by energy need and equipment number. For the fan, we have a 70, 70 and 1 for the equipment number. The should model. The should model a line for evaluation the energy need and energy consumption. For example, the energy need is defined by the formula need equality P multiplied by number. The consumption of a household group. The consumption is the consumption equality consumption multiplied by consumption the energy consumption. The first part, the simulation. The period, we have a free period of the study. The first period, the rainy season from June to October. The dry season from November to February. The autumn season from March to May. The data, the climate data cover the period from 2022 2024. The property of the model. The simulation is that every 1 hour the simulation spent over a week. Three simulation scenario of the study. We have hot period, rainy period, and dry period. Here we have the number also of each region. For example of a region, we have the center est, the center north, the center west. The result of the simulation. The first scenario have the auto period. Here we have a center region, Haute-Obasan region, Southwest region are the biggest energy consumer. The second scenario is a rainy period. Here we have a center region, Haute-Basin region, North region, Southwest region are biggest energy consumer. The first scenario, the dry period. Here we have a center Haute Basin, North Southwest are the biggest energy consumer. Finally, the conclusion, summary and outload achievement simulate the overall behavior of the model in Gamma platform. Visually, the result of the model simulation. The limitation. The work does not take into account household individual. The variation of a given type of equipment within a household is not taken into account of the study. A fitted directive. We plan to expand the study to the regional and national scale. Evaluate the energy consumption of industry and the sector in the main city of the country. The references are the end of the presentation. Thank you.
Thank you so much for the presentation. Do we have any questions?
Yes. Just tell me why you use that, why you use basically that multi-agent system, right? Instead of there are the machine learning, deep learning models are there, generally we use for the household energy demand prediction. So how the MAS, that is the multi-agent system, is different from that? Can you elaborate on this?
I don't understand your
Uh,
question.
I'm asking why the multi-agent system you have used instead of the traditional machine learning or the deep learning models, which is generally used for the energy prediction.
Yes, sir. Yes, sir. Various of the machine learning and deep learning for using the evaluation, the prediction, energy, household energy consumption. In your case, we use the multi agent system, for prediction for to household energy. It is okay.
Yeah, okay. Okay, ma'am. Yeah.
Okay, thank you so much. Dear presenter, you can start presenting your screen now. Dear presenter, you may stop sharing your screen now. Okay, thank you so much. Next, we have Samarth Roth with the paper title of AI-driven next generation firewall for dynamic threat detection using zero trust architecture. Dear presenter, dear presenter, you may start presenting. Dear presenter, you're not audible.
Hello, I'm audible.
Sir, your voice is very low.
Hello, hello, I'm audible.
Yes, sir. Yes, sir.
Good afternoon, everyone. I am Samarth Raut and I am presenting our research paper.
I think you are not audible.
Good afternoon, everyone.
This is okay.
Good afternoon, everyone. I am Samarth Raut and I am presenting our research paper titled AI-driven next generation firewall for dynamic threat detection using zero trust architecture. My co-authors are Rohit Savashe, Saurabh Tiwari, and our mentors are Dr. Vidya Damdere and Girish Awadmal from GHRCM Pune. Uh, let's begin by understanding why we need AI-driven next-generation firewall. Traditionally,
Dear presenter,
yes,
are you presenting your screen?
yes.
We cannot see the screen, sir.
Is my screen visible?
Yes, sir.
Good afternoon, everyone. Myself, Samarth Raut, and I am presenting our research paper titled AI-driven next-generation firewall for dynamic threat detection using zero trust architecture. My co-authors are Rohit Savashe, Saurabh Tiwari, and our mentors are Dr. Vidya Damdare and Girish Awadwal from GHRCM Pune.
Dear presenter, I'm so sorry to interrupt, but you are not very audible.
Let's begin by understanding why we need AI-driven next-generation firewall. Traditional firewalls depends on fixed signature and fixed rules and predefined signature. Although they work well on known attacks, but they struggle to detect modern attacks such as zero-day attacks. Existing machine learning-based intrusion detection system can detect malicious traffic, but most of them only generate alerts and do not automatically block attackers. Similarly, with zero trust implementation provides good access control, but most of them policies lack intelligent threat detection. So, modern networks demand automated detection and real-time blocking. Therefore, our objective is to develop an intelligent firewall capable of real-time attack detection and automatic blocking. System architecture. Our proposed system has a sequential pipeline. Initially, network traffic is captured using SCAPI. After that, 52 statistical features are extracted using a machine learning model. This machine learning model analyzes that features and detects whether is normal traffic or attack. After that, zero trust engine dynamically updates trust score, and based on the machine learning based detection and zero trust score, firewall makes decision whether to allow or block that IP address. All these events are stored in database, which are which will be displayed on the dashboard for real-time monitoring and analysis, dataset and feature extraction. For our experiment, we use CIC IDS 2017 dataset. It is the most widely used dataset for IDS research. It contains 7 traffic classes over normal plus 6 attack types, which includes normal traffic, DOS, DDoS, port scan, brute force, and web attack and bots. Our system extracts 52 features, which includes flow features, packet statistics, inter-arrival time, TCP flags and headers, and subflow features. After that, uh, we evaluated our system by using three ensemble learning machine models such as random forest, XGBoost, and LightGBM. All of this model achieved excellent performance, but LightGBM was selected because it achieved accuracy of 99.79%, F1 score of 99.79%, and fastest training time among all other models. So LightGBM is selected as a final deployment model. Along with machine learning based threat detection, we also implemented zero trust scoring mechanism, which is our novelty. Initially, every IP address has trust score of 100. If some malicious traffic is detected, trust score will be decreased by 30 as a penalty. If normal traffic is observed, trust score will be increased by 0.1%, 0.1 as a reward. And when trust score falls below 40, the system automatically blocks that IP address. After that, uh, experimental result, our system achieved excellent performance. It achieved accuracy of 99.79%, F1 score of 99.79%, and precision of 99.80%. High precision minimizes the false positive and improves reliable threat detection. And our system also achieved response time is less than 100 millisecond, which enables real-time IDS and firewall enforcement. Compared to existing system, our proposed AI-driven next-generation firewall has several advantages. It includes AI-based machine learning, while existing system only use static rules fault detection. Uh, Fault detection, our system not only detect but also automatically blocks that IP address if it is found that is malicious, while existing traditional system only detects and generate alerts without blocking them. In our system, we also implemented zero trust architecture, which dynamically updates trust score, which reduces false positives and mm, prevent malicious behavior repeated. We also uh, we also use the real-time streamlined dashboard for displaying the all data, which is help for analysis. Future work. In future, we plan to enhance detection using deep learning models like LSTM and CNN. We also plan to deploy system in cloud and distributed environments for privacy preserving and zero-day attack detection. After that, finally, in conclusion, we develop a AI-driven next-generation firewall with integrated zero trust architecture. Our system has accuracy of 99.79%, which is good for real-time monitoring of data and suitable for real-time network security and network protection. Thank you.
Thank you so much. Do we have any questions?
Yes, just tell me that whether your framework continuously verifies the users and devices, or you are just performing the or it is performing the authentication during the initial access only.
No, it continuously verifies the IP address and
Hmm?
dynamically changes its trust score, which reduces false positive and minimizes the repeated malicious event.
Okay, okay. And how it you are enforcing through your firewall, proposed firewall that never trust and always verify principle during active network sessions, right? Whenever the traffic is continuously coming.
We set a trust score. Initially, every IP address has, I explain in this slide. Initially, every IP address has trust score of 100. If
Hmm?
some malicious traffic is detected, trust score
Hmm?
is decreased by 30 as a penalty. And we set
Okay.
penalty 30 because if some malicious uh, event is found, it quickly decreases trust. And we also set a reward of zero point 0.1, which is less as compared to penalty because we When uh, trusted devices are found, they gradually increase the trust score, not direct inflation of trust score. Therefore, we set reward only zero point 0.1, and when trust score will goes down beyond 40, the
Hmm.
system will automatically block that IP address.
Okay.
The needs had some of the measure on the data,
Yes.
how they are deriving the data for connected services. And
Yes, Sirali, I'm done.
Okay, thank you so much, ma'am. Presenter, you may stop presenting. Okay, now we have Induja M with the paper title Benchmarking of Online Edge AI and Cloud AI Performance in Video Surveillance. Dear presenter, you may start presenting.
Is my screen visible?
Yes, ma'am.
So, good afternoon, everyone. I am Indujayam from the Department of MC, RNS Institution of Technology. Today, I am going to present our research paper titled Benchmarking Offline Edge AI and Cloud AI Performance in Video Surveillance. This work is done along with my co-workers Jashwant K and Vishwanath P. Murthy. In this research, we compare two AI approaches used in surveillance system, Edge AI and Cloud AI, and evaluate them based on latency, scalability, energy efficient, bandwidth, and privacy. So today's surveillance systems are used almost everywhere. For example, in traffic monitoring, railways, airports, hospitals, and all. All these surveillance systems generate a huge amount of video data. The biggest question is where should all AI process this video? There are two possibilities. The first is cloud AI, where video is sent to cloud servers like AWS or Azure for processing. And the second is edge AI, where AI processing happens directly on the local devices such as Raspberry Pi or Jetson Nano. Both approaches have advantages and disadvantages. Until now, there are no systematic comparison between two approaches. Uh, Now let's understand some basic difference. In Edge AI, processing happens near the camera. Since the data doesn't travel over the internet, the response is very fast. Like the latency is only around 10 to 50 milliseconds. Privacy is also better because video remains inside the organization. However, edge devices have limited computational power, so they can only run lightweight models like MobileNet or YOLO V5S. On the other hand, cloud AI process data in a powerful cloud servers. It supports very large AI models like YOLO V8 and transformer models. So cloud AI is highly scalable and can manage thousands of cameras. However, video has to travel through the internet, which increases the latency around 100 to 300 milliseconds. So this also consumes higher bandwidth and raises privacy concerns. This slide explains how both systems works. In Edge AI, the camera capture video, embedded device process it immediately, and they detect the object, make decisions, and they send only alerts. This improves privacy and also reduce latency. But in the cloud AI, the camera continuously sends the video to cloud servers. The cloud performs object detection and stored videos, updates AI models, and performs advanced analytics. Cloud offers higher computational power, but it depends completely on internet connectivity. So the system architecture in Edge AI, the CCTV camera sends the data to edge devices like a Raspberry Pi, and the AI model runs locally using a lightweight model like MobileNet or YOLO V5S. Only important events or alerts are transmitted. But in the cloud AI, all camera streams are sent through the internet to cloud platforms such as AWS or Azure. So powerful GPU process the videos using complex AI models like YOLO V8. The cloud also perform long-term storage and retaining. The challenges in AI-based surveillance is the first one is a network dependency. So cloud AI cannot work efficiently without a stable internet connection. And the second one is the bandwidth. Streaming HD videos from hundred of cameras consumes enormous bandwidth. And third is latency. For applications like accident monitoring or intrusion detection, even a delay of a few hundred milliseconds may be critical. And the fourth challenge is the privacy. Sensitive videos are stored in the cloud servers, which increases security risk. And the fifth is the hardware limitation. Edge devices have limited CPU, GPU, and memory. And the final is the scalability. Cloud systems scale much more easily than the edge devices. And these are the literature review where many motivated this work to show there is no complete comparison between the offline edge AI and cloud AI in the surveillance system. While the cloud AI is suitable for the heavy processing based on these studies. Our methodology compares three approaches. The first is the edge AI. Here, AI model runs locally, and the advantages is low latency, better privacy, and lower bandwidth and real-time detection. And then the second is a cloud AI. Video is transmitted to cloud servers where powerful GPU perform object detection, where face recognition and activity analysis. This provides excellent scalability, but requires higher bandwidth and internet connectivity. So finally, we studied a hybrid model which combines both approaches. The hybrid model combines the strengths of both systems. The edge devices perform immediate object detection and real-time decision making. The cloud perform heavy computational, long-term storage analytics, and model retaining. For example, in a smart traffic system, the edge device detects traffic violation instantly, while the cloud analyzes traffic patterns over several months. This provides both real-time performance and scalability. The results. In terms of latency, Edge AI performs much better, making it ideal for real time surveillance. In terms of scalability, cloud is superior uh, because powerful servers can process thousands of cameras simultaneously. Regarding energy efficiency, Edge AI consumes less power because only the processed information is transmitted. And for the privacy and security, Edge AI again performs better since sensitive videos never leaves the local devices. Overall, the result indicate that neither technology is universally better, but each perform best under different conditions. And the conclusion, Edge AI and Cloud AI should not be considered competitors. Instead, they complement each other. Like edge AI is best for real time, low latency, privacy, and all. But cloud AI is best for large scale analytics, model training, and centralized management. Therefore, the future of intelligent surveillance lies on the hybrid AI, which combines real time local processing with cloud based analytics. This approach provides the best balance between speed, accuracy, privacy, and scalability. And thank you.
Thank you so much. Do we have any questions?
Yes. Yes. Have you worked on this proposed hybrid approach, or it is you are just proposing it now?
We have proposing it now as we have studied the latest references. We have got this idea and researching about it.
What is your contribution here in the benchmarking study beyond the existing comparison in the literature about AGI and cloud AI for video surveillance?
Sorry.
What is your primary contribution of your benchmarking study? This is a study paper, right? Review paper.
Yeah.
Yeah. Beyond the because the existing comparison is there in the literature. So I want to ask your contribution in the existing study of the cloud AI and edge AI for the video surveillance?
Yeah, the conclusion is that Edge AI and Cloud AI each has their own strength, but Edge AI performs a faster response, and the Cloud AI has a greater scalability and everything. But the best choice depends upon the application's requirement in many cases. The hybrid approach that combines both Edge AI and Cloud that delivers the best overall performance. We can't use only the separate cloud in surveillance system or separate edge. We need to combine both.
Is there any other existing model which is combining the both?
Uh, Existing models like
Which are already
YOLO.
combined, yeah, which is already combined both like hybrid approach.
Still, hybrid approach is not yet there. For the separate, like for Edge AI, separate Raspberry Pi is there. For the sub cloud Azure, no, there's no not yet combined one, hybrid one.
Okay, okay, thank you.
Yeah, thank you.
Thank you so much. Up next is Akash Dulange with the paper titled Drug Inventory and Supply Chain Tracking System.
Akash, could you present the screen?
I'm sorry, you weren't audible.
Hello. Am I audible now?
Yes, presenter, you may start presenting.
Yeah, sure. Akash, could you present the screen, please? Akash? Yeah. Could you zoom in? Start from the first slide. So, good afternoon, ladies and gentlemen. I'm Aditya Patwa. I'm from GSPM RSCOE. And the name of our topic is Drug Inventory and Supply Chain Management System. So, to give you a bit of backstory of our entire topic. So, at the start of third year, we were deciding which project to work on, and we were a bit in a quandary in finding what project to work on, but weren't getting anywhere. So one day, my uncle owns a medical store. So I went to his medical store, I was sitting there, and I noticed that the system which he uses to manage all the drug and supply that comes and goes out is kind of outdated. The system was actually Stocks. There are different systems as well in the market currently, but those systems are either very expensive or not advanced enough for a good use. So what we decided was to fill this gap. For example, Medistock, which is which is highly prone to human error, and since you know that whenever human comes into picture, there always will be errors. Then there is no automated reordering for Medistock. There is data inaccuracy and poor coordination between the supplier, manufacturer, and the end customer. So, Akash, could you next slide, please? Yeah. So, as I already told you, the problem statement. So we decided to make a web-based system, basically for drug inventory and supply chain management. The primary objective of the system was to digitalize and automate pharmaceutical inventory management while improving the supply chain efficiency. The system provides real-time monitoring of stock levels. We've also provided graphics to easily navigate through stock levels. And yeah, next slide, please, Akash. Yeah. So it automates the inventory, it tracks the expiry dates, supply chain management, and order processing. By maintaining complete records of medicines, suppliers, and transactions, the system improves traceability and it also minimizes human errors, which is a win in its own way. Additionally, it generates reports and inventory insights that support better planning and decision making. When it comes to what medicines are coming into the medical and what medicines are going out. Then we've also integrated it with artificial intelligence because since it's the day and age of AI, and in order to make good use of it, what we've done is, for example, when in colds or rainy season, there is rather increase in cough syrups, or maybe in medicines which is related to fever, etc., viral infections. So there is a surge in this order. It's very rare that the pharmacist orders it first initially, and so what we do is we use AI to automatically order this. We use AI to automatically alert the system that the stock is below a certain level, and because it's below a certain level, you need to order. Or we have also included with an automated reordering system, which basically you don't have to do anything. It's once the stock level is below a certain limit, it automatically orders and you'll get the delivery as expected. One thing I'll also like to say, yeah, these are the technologies used. HTML, CSS for the basic front end. Then there is MySQL Java for backend, and uh, yeah, crude MySQL database implements the core business logic. Yeah. Then the system workflow where user authentication, the user logs into the system. I'll just quickly go through the proposed methodology. User logs into the system using secure credentials to access the application based on authorized permission. Then there is dashboard access like in any other website you'll find after a successful login. The dashboard provides an overview of inventory status, quick access to different management modules. And there is inventory management. Users can add, update, delete, search medicine records in the system. One more thing I'd like to tell is that, for example, me as a customer, we are also planning on making a provision that, for example, I need a certain medicine which is available in only one of the four medicines nearby. So what it does is, once I log into the app, I get to know that which particular medical is has this particular medicine, so that my efforts are also saved in the process. Then there is order and stock management. The system records incoming and outgoing medicine transactions, automatically updating stock quantities in the database. There is database processing. All inventory, supplier, user, and transaction data are securely stored, managed in the MySQL database through PHP. Monitoring reports, the system monitors stock availability, expiry dates, while generating reports that help user analyze inventory status. So we've also provided the user with graphs and various bar graphs, histograms to help him analyze his business in a more profound way. Akash, next slide, please. Yeah, function modules, inventory, user authentication, again, inventory management. One more thing I'd like to include here is that we're also planning on using blockchain in this. See, because there have been quite a few incidents now. The recent Bihar cough syrup incidents, wherein people were taking cough syrups uh, without any prescription from the doctor. So, in order to prevent that, we've also included blockchain in it, so that this helps prevent illegal use of drugs. That is, we can track each and every medicine to its last customer, or at least to the pharmacist who is selling those particular cough syrups, or any particular drug. Because the thing that happened was, because the pharmacist could order any amount of medicines without any accountability for whom he is selling. That was actually a problem, and blockchain solves that problem. Yeah. So next slide, please, Akash. So coming to conclusion and future work, the application provides a centralized and efficient web-based solution for managing drug inventory and supply chain operations. The system automates inventory management, reducing manual effort and minimizing human errors. Real-time stock monitoring and supply management help maintain accurate inventory records and improve operational efficiency. By digitalizing pharmaceutical inventory processes, it enhances transparency, supports better decision making, and ensures timely availability for medicines. Also, one more thing is that future work, we're planning to integrate it with barcode and QR scanning for faster medicine identification and inventory updates, which is basically at for example, at a store like DMart, you go, the cashier there uses the QR code to automatically give you a bill. So in the same way, what we do is that once we get the, for example, I'm a pharmacist and I get an order. What I'll do is I'll use the help of the barcode to scan the order, and the inventory which I have will automatically get updated. And once the order is, for example, a customer comes and takes a particular medicine, I'll again scan the barcode, which will indicate that the medicine has been sold and my inventory will automatically be reduced. And there is we'll also planning to add email and notifications for low stock low stock expiry and reorder alerts. Deploying this application on the cloud to support secure remote access and scalability. Next slide, please, Akash. These are the references which we've used. You can go through them for the research and study of this particular project. Thank you so much. Any questions, please?
Hello. Yes, Akash, can you tell me how your system improves transparency and we can say the traceability across the pharmaceutical supply chain?
Okay. Give me a minute. The thing is that we've used blockchain to this particular for this particular thing, and in the current version, users provide feedback as well regarding the inventory operations. This feedback helps analysts identify issues and improve the system. In the future, as I said, I'm planning to use blockchain. The reason is that with the help of blockchain, as we know, the blockchain system, you can trace it back to the original user who is buying or selling the particular medicine. So, in case there is an illegal use of the drug or buying of a drug, we'll be able to know that if we just trace the blockchain back to the original seller or product. Yeah.
Do you have the model developed for this all?
We've developed it partially, but we're still in the process.
Okay, okay. And one more thing, does your system support centralized or decentralized inventory management?
It's a centralized inventory management.
Okay.
Yeah.
Okay, good.
Anything else?
Yes, no, thank you.
Thank you so much for listening so patiently. Have a nice day.
Thank you so much. Dear presenter, you may stop presenting your screen now.
Akash. Yeah, thank you.
Thank you. Next, we have Nishchala GS with the paper title Hybrid Adaptive Chaotic Opposition Based Particle Swarm Optimization HACOPSO for Dynamic Multi-Objective Ship Routing. Dear presenter, you may start presenting.
Hello, am I audible?
Yes, sir.
And the presentation is visible, right?
No, not yet, sir.
Just give me 1 second. One second. I'll just rejoin 1 second. Sorry. Can you see the presentation? Hello, is the presentation visible, ma'am?
Yes, sir.
Thank you. I'll start now. Very good afternoon to everybody present here. I am Nishla GS, and I'm here to present our paper titled Hybrid Adaptive Chaotic Opposition-Based Particle Swarm Optimization. It is for dynamic multi-objective ship routing. So basically, what is the current trend in the shipping industry is more than 80% of the trade across the world is going through the ship, that is through the waterways itself. So now, because of the recent events such as the Hormuz crisis and the Iran war, there is a lot of cost driven cost is being risen across the board because of this So the fuel burned, the duration, safety, such as the pirate zones, etc. They're governed by the wind, ocean currents, etc., and other factors as well. And traditional methods such as a Dijkstra's algorithm or a Floyd algorithm or any deterministic shortest route algorithm, they just take only one assumption, that is to find the shortest route. But we are here, our core idea is to have multiple objectives at once. That is the fuel, the weather conditions, and all the other possible factors to be taken into account before generating the best possible optimal route. Next, objectives. So first objective is to develop a unified swarm optimization framework. Now, traditional particle swarm optimization doesn't have inertia control, opposition-based learning, and chaotic local refinement. But we are combining all of these things into a traditional PSO to form this unique framework called as the COPSO framework. That is the hybrid adaptive chaotic optimization particle swarm optimization framework. And multi-objective formulation, as I told, the total voyage time, the total fuel consumption, and the total risk that is due to the pirate zones or due to the tsunami zones, etc. They will be covered here. And we try to get the premature convergence. Best possible route may or may not be found. So we try to escape the premature convergence, and we try to have opposition-based initialization and chaotic delocalization. And the weights are dynamically readjusted at every point in time so as to ensure that all the factors get taken into account. And this is validated against SPSO, that is the standard particle swarm optimization, APSO, CPSO, and all. We have generated simulation data for Indian Ocean corridors and also for Turkey HSD testing also we have done. So aim and scope, as I discussed, it is to develop this framework, hybrid adaptive chaotic opposition based particle swarm optimization framework for us, and try to have the multiple weight factors considered here. So you can see the formula that we're using, and the scope is to, there's a problem, the vessel will be there. The data such as from the Copernicus and the NOAA, that is from the National Oceanographic and Atmospheric Organization data, we take such as wind velocity, ocean currents, etc. And we try to generate multiple different scenarios such as normal, moderate, and severe, and then compare it against the baselines. So let me talk to you about the system architecture now. So in the system architecture, so the first input layer, the people or the ship routers, they have to input the route segments. Then the wind current wave or whatever factor should be there, that will be taken into account by the APIs that we are using. Or also we are trying to place some inboard sensors into the ship itself to capture real-time data. And the fuel time disk weights are already initialized. Then we are going to set some random population, the opposition particles, and diverse search coverage for this issue. And the COPSA engine, there is adaptive inertia and the quantum position update. So here we are using on the top of the COPSA engine, at the final layer, we are using a two-layer quantum variational circuit in order to optimize the best route that can be possible, because this at core is an optimization problem, and currently quantum is leading the state of the art in the optimization approach. So we are using this. Then we calculate this composite fitness score, and the chaotic refinement score is calculated. And then a Pareto layer is introduced, where a non-dominated sorting or a crowding distance is also found there. And then methodology. So first inputs, as I told, then the initialization is done. Evaluation of the same using the various factors that I mentioned. Then upon the baseline, we try to improve it using the adaptive PSO, and then select the best possible route. So these are the essential equations that are required, and this is the algorithm for a particular one route. So next, the data sets we have used. So for environmental data, as I told, it's the Copernicus and the NOAA products. For route, it is the route shipping corridors data that we get from the trade organizations and the maritime organizations. And all the time.
આપણે ઓક્ટોબરમાં ગયા હતા ને દિવાળીમાં.
Ma'am, there are different weather scenarios that are generated, such as normal, moderate, severe. And the experimental setup is via Python and MATLAB or an Intel i5 we have used. And these are the experimental results we got. So approximately 18% of the fuel is saved in the simulations that we ran. 14% time is reduced as compared to the normal PSO, measured in terms of hours. And there's a 23% reduction in the risk that is calculated. For this, we have run multiple simulations across different routes and calculated upon the number of crimes or hijackings that have taken place in that particular routing. And compared to a traditional PSO, there is a 43% better chance of convergence in this framework. And these are the experimental results, the statistical significance, the computational complexity, and the graphs for the same. And this is the previous results. See. And in the future enhancement section, we are trying to include a full Pareto-based multiple objective extension and try to time integrate of the data using the sensors that we try to board onto the ships. And they're not in just on Indian Ocean region, but also across the world. We try to include this. And the computation optimization for a normal CPU, if you can run it, then it would be better for us and the results as well. And so the conclusion is it is novel hybrid PSO framework which unifies inertia control, opposition-based learning, and quantum-inspired position updates. And it directly addresses a gap in existing literatures because there's no prior maritime routing PSO combining all the four mechanisms. And this has already been implemented and tested or validated against the Indian Ocean corridors. And it consistently outperformed all the traditional algorithms on every metric and highest per run cost that is approximately twice that of the PSO is pretty acceptable because there's a gain in quality and the robustness as well. Yes, thank you, and I'll be happy to answer any questions.
Yes, can you tell me how frequently this opposition-based learning approach you are applied during optimization, and does it increasing the computational overhead or not?
Ma'am, yes, it increases the computational overhead. The opposition-based learning is not used for the baseline value that we get, but upon the baseline value, when we try to adopt using this, because this is essentially a genetic algorithm, then the opposition comes into the picture and we try to improvise upon that baseline. And yes, it increases the computational overhead. As I told, it is approximately twice that of the standard PSC.
So is there anything which you can improve on that to reduce the computational overhead? Obviously, overhead is there. That's why the time required would be the more.
Yes, ma'am. So currently we think it is acceptable for this trade-off, but in the future we would try to reduce it because essentially the time should be the same as that of a standard PSO that we would want it to work upon. But currently we think it is acceptable because the results that we are getting is comparatively way more better compared to any standard PSO or other PSO variants.
Okay. And Hackopso you are used. So how it is balancing the exploration and exploitation during the search process?
Ma'am, so first of all, if I take any route possible, it explores all the possible routes from that particular port to the other destination port. Suppose there are 1,000 different routes, it explores all the 1,000 different possible routes. Then it chooses a baseline route and then it tries to adapt upon it. And the concept of yeah, basically.
Okay. Okay. Thank you.
Thank you so much.
Thank you so much.
Next, we have Yash Dilkhush with the paper title Indian Cuisine Intelligence Proposed Food Recognition and Nutrient Estimation Framework with Ingredient Retrieval Using Deep Learning. Dear presenter, you may start presenting.
Yes, ma'am. My screen is visible, ma'am.
Yes, sir.
So, hello everyone. My name is Yash Dilkhush, and I represented my research problem, that is the Indian Cuisine Intelligence Proposed Food Recognition and Nutrition Estimation Framework with the ingredient data using deep learning, along with my the authors, which is one Sadariwal, and under the guidance of Dr. Nirali Nanavati. And we are from the State Sarvajanik College of Engineering and Technology from Surat. So here is the outline of this presentation: introduction and the current challenges, objective literature, and the proposed solution, and the implementation and the analysis and conclusion and the future goal. So first, the introduction. So food ingredient detection with AI. So in the rapid growth of the food delivery and platforms like Swiggy and Zomato recognition the food disease, and based on that we order the food by saying the ingredients it is helpful for our health or not. Ingredients becomes images has become important in the food analysis. So what are the current issues we are facing in the Indian food dishes? Right. So ingredients cannot be easily identified by the looking at them and making the accurate detection. And so the major challenges in the food dishes like appearance and the camera angles, color gradients. Based on that, we cannot detect that what the exactly ingredients is present or in your food. So we uses the deep learning approach detect the food disease, and based on that it retrieves the ingredients like major ingredients. It's used based on that macromolecules also we analyze that. So our aim is to develop the deep learning model and to detect the key ingredients, some images of the food disease, and we focus also with the Indian food disease. So we use the four models: ResNet 50, Efficient Net P0, P1, and the mobile net P2. So in the among these four models, the ResNet 50 is accurately detect the food disease, and we uses the predefined CSV dataset by using the maps the each dish to its ingredients. So these are the literature review what we papers got from the research. So AI-based food image processing. This is one of the paper we found that which model I need to use, and how the approach is from that. And based on the nutrition tracking, we use the second paper as a main source. So we the So our research like ResNet 50 and MobileNet and the EfficientNet has strong performance in the code recognition tasks. And the research highlights like in detecting the multiple ingredients due to the version and mixed textures and high similarity among the species and the food items. So our data set from the Kaggle, that is a massive Indian food data set, which are around having images like 4,770 images, and we split into the 80-20-10 ratio. And we worked on the 15 classes like such as biryani, dosa, kathirol, chole bhature, and many of that of the Indian food dish. And we use this model as I earlier said, ResNet 50, EfficientNet B0 and B1 and MobileNet B2, and we use the deep learning architectures from identifying the dish and predicting that corresponding ingredients from the CSV predefined CSV dataset. So these are the model comparisons we done that among this the recent 50 are well performed on that on the real world dataset, while the validation accuracy performed well of the efficient net P0, and the training time of the recent 50 will be greater than among these data sets, so it performed well on the real world data set. So these are the result of the ResNet 50 model. So confusion matrix. These are what are the challenges we are facing on that? We facing on the camera angles, similar colors and the texture variations like that in the lighting also. So we cannot predict it, as you can see that the Vodafone and the Davali has different variation. Due to that, it predict uh, wrong classes like that. So the confusion matrix helps the in understanding the class-wide performance where the model can be fine-tuned. So our model Resident 50 achieved the 94.74% of the on the based on the Kaggle data set, and strong showing the strong generalization on the complex Indian food disease, and we utilize the based on that detecting the food disease, and based on that the predefined CSV data web with the mathematical equation, we highly scalable automate the solution for the ingredient retrieval. And the dietary nutrition, we use this the 4 to 1 ratio method to analyze the nutrition tracking. So our future work is to enlarge the data set to include a wider variety of the foods, because we worked on the 15 defined data set. That's why. And we can also develop the dedicated mobile application utilizing the depth sensing or the multiple camera setup to estimate the exact nutrition weights. So these are the references which we refer to make this happen. So uh, if you want, so I can show the live demo also, ma'am. Are you able to see my screen, ma'am?
Yes,
Yes.
sir.
Like we can analyze it, and it shows the major ingredients of the particular dish. Like it is a dosa, so it's gives the rice, salt, oil, ghee, onions, like major ingredients it can show. And based on that, if we say like it is 200 gram as per the estimated weight, so can check that it gives the calories as a 300 calorie, and based on that the percentage 4 to 1 ratio. So it gives the this results. So if there are any questions, so let me know.
Can you tell me that how many food categories are included in your system? And
Actually,
how?
ma'am,
Okay.
there are the 15 classes which we define, like this biryani, chole bhature, like dhokla.
Okay, as you shown in the confusion matrix.
Yes.
So how you are handling that class imbalance among the different Indian dishes?
Uh, we use a Kaggle dataset. Based on that, we process some augmentation methods to balance the data sets, and we train the model based on them.
Okay. And as you are considering the Indian cuisine, right? So there is a regional variations in Indian cuisine, where the
Yes,
same
yes,
dish may have the different ingredients or the different preparation methods. It
yes.
varies region to region. Even in same state, also region wise, it is varying. So
Yes, yes.
how it can be addressed?
Actually, right now we are focused on the major ingredient. Like if the dosa is that, then it will be the rice will definitely come on that, and salt also that, and ghee also that, onions also that, coriander leaves also that, like that.
Okay. Yes.
Any question? Anything else?
No.
Thank you so much. Next, we have Bhanushri CM with the paper title Multi-Dimension Static Feature Fusion for Android Malware Detection Using Random Forest Ensembles. Dear presenter, you may start presenting.
Yeah, good afternoon. I'm Anjana Pranati M, one of the authors of this paper. I'll be presenting on behalf of Banashri. Due to medical reasons, she won't be able to present.
Sure, no problem.
Yeah. I'll share my screen. So our paper title will be Multi-Dimension Static Feature Fusion for Android Malware Detection. The authors are, along with me, Diyaprada Vasudev, Anjana Pranati, Banashri, Chetan Hemant. We are from the institution Danan Sagar Academy of Technology and Management. So the introduction, basically, the whatever project we have developed is named ShieldX. So it is basically a machine learning based tool for detecting malicious Android applications. It is a web-based interface where users can upload or select an APK to be analyzed for potentially harmful behavior. Why did we choose this problem statement is, as we can see, a simple calculator app asking for a location or contact permission, which is suspicious and may indicate a privacy risk. So traditional antivirus solutions, which are already there, often fail to detect such hidden behaviors, whereas our project addresses this problem by using an AI-based analysis to identify the privacy threats and protect the user's data effectively. So before taking up this problem statement, we have referred these are the few papers which we have referred, and the gaps which we have found out is the existing Android malware detection techniques mainly focuses on a single type of static feature, such as permissions, API calls, or intents, resulting in a limited detection capability. Whereas what we use is we merge the API calls, the intents, everything for a better approach. The signature-based approaches are ineffective against the newly emerging malware attacks, and many existing machine learning models provide only binary predictions. They don't provide the confidence scores behind the decisions, and several state-of-art approaches rely only on the cloud-based analysis. So this is also one of the visibility gap which we got, and there's a lack of lightweight or interpretable or deployable solutions which can be deployed on the apps for checking the same. And the functions used, our system follows a clear pipeline. Once we have built the step is the APK is decompiled using the JETAX to access its code. Next, we perform feature extraction, focusing on permissions, intents, and API calls that may indicate the malicious behavior. So the third, we have these features are then transformed into numerical vectors and passed to the random forest classifier. Why we have choose random forest classifier is for its being it giving the highest accuracy, and it also well handles the high dimensional data. So after that, finally, the Streamlit UI generates a detailed report showing the confidence values for each dataset, and the dataset we have been used for this is Chimera dataset. To develop this, the hardware and software requirements will be the laptop with a recommended 16 GB and a multi-core CPU. The softwares will be Python 3.9, Streamlit, Docker, Java JDK 8, and a pip library. The architecture of the project has been divided into two main layers, the front end and the back end. The front end being built using the Streamlit and which runs on a local web application. It also allows the users to upload the APK files, start the analysis, and then view results such as malware or benign classifications. The backend handles feature extraction and malware classification. It extracts the permissions, intents, and API calls from that APK. These features are analyzed using a random forest machine learning model. And this we also have used Docker for the system containerization. And there's the flow diagram or the methodology of the project. And then coming to the first part of the diagram, the process begins with uploading the APK file as mentioned. The JADAX and APK readers are used for extracting the APK file. After extracting, feature extraction and feature selection. The feature extraction, this block converts the class files, intents, and permissions into quantifiable feature. Feature selection, the extracted features are further filtered to select the most relevant ones. For example, the files like api.json and intent permission.json served as a structured feature sets for model training. Next phase is the model training and development. So the permissions, intents, and API calls that have been extracted are given as an input to the model, and each model is deployed as a containerized service. These models are independently responsible for analyzing a specific feature set. Aggregation or output, the prediction from all the models are aggregated. The aggregated output determines if the APK is classified as a malware or benign. So this is the implementation flowchart, the project setup, and APK assembly and feature extraction. Next is a feature selection. These are the few of the snapshots of our working project. So there's the thing, and the first will be the uploading the APK thing, and then the next part will be the model training and deployment, prediction aggregation, user interaction, and reporting. So here we also can see the graphs of how much data it will analyze in a specified time. So the API vectors, these are what are extracted from that, and this is the flow graph that represents the Chimera intents, permissions, and merged. So it will also show the confidence scores, and this is the final classification that it will be shown whether an APK is a malware or a benign. So conclusion, Sheetex provides an effective and user-friendly framework for Android malware detection, which combines the API calls, permissions, and intents with a random forest classifier. So the modular architecture, which is Docker based, so which gives a higher end for it. And the future enhancements, what we have thought for this is expand the data sets and provide it as a cloud and a mobile deployment so that it will be easily usable rather than web based, what we have currently. Thank you.
Thank you so much. Do we have any questions?
Hello. Why did you choose that random forest ensemble over the other classifiers like SGBoost is there, LightGBeam or other deep learning one?
Because it actually provided a higher accuracy. We actually trained it with all the models, but this provided higher accuracy, and it also reduces the overfitting. So it handles the high dimensional data well. So we preferred using this.
Okay. And what categories of static features you are using in your framework? Means, for example,
APK is basically after extracting, it will have permissions and intents and API calls. So these are the static features which will be extracting and using it for the training the model.
And how you are determining that which feature has which all the different features has contributed more significantly to the malware detection?
Yeah, the existing models, what they have is each feature is analyzed. So that is not helping to find out or figure out what is wrong or what is what is wrong. So what we have done is we have merged the two intents and then we have tried to analyze it. So which gave a more analyzed way than the existing ones. So the existing ones, they only permissions or only intents are used, but we have tried using both. So which gave us a better results.
Okay. Okay, thank you.
Thank you so much. Dear presenter, you can stop presenting your screen. Now we have Snikita Govindu with the paper title Swarm Optimized Latent Diffusion Framework for Sketch to Face Image Generation. Dear presenter, you may start presenting.
Is my screen visible?
Yes, ma'am.
Great. So good afternoon, everyone. This is Nikita. I'm going to be presenting our paper, Swarm Optimized Latent Diffusion Framework for Sketch-to-Face Image Generation. The author names are Rudroju Sai Venkat, Girikanti Shrikant, Akshata Nikita, and Krishnaveni. We are from the college CBIT. It's in Hyderabad. So moving on. In this presentation, I'm just going to outline whatever our literature survey was, whatever the data set we've used, system architecture, some of the implementation details, and the evaluation and the results and the analysis of those. So, introduction. A hand-drawn sketch contains very limited information, so it usually has only outlines and lacks color, texture, and shading. Yet humans can still recognize a face from it. So we wanted to implement the same but using a machine. So generating a realistic face from a sketch is useful in areas such as forensic investigations, digital art, or interactive design systems. So earlier GAN-based methods like Pix2Pix and CycleGAN could perform sketch-to-face translation, but they often suffered from unstable training and model collapse. So diffusion models provide a better and more stable generation process, but the challenge is to produce a more realistic face while preserving the structure of the original sketch. So a variational autoencoder compresses 128 into 128 face images, and then this makes the diffusion computationally affordable. Second, then we are going to a latent DDPM model, which learns to denoise these latent vectors. Thirdly, we are going to use a veil optimization algorithm, which is one of the swarm optimized techniques, which is also a meta heuristic algorithm to automatically find the best value. So this complete pipeline is we use Kaggle and we also use the GPU NVIDIA 100. Moving on, our objective is to create a compact latent representation. Is to also provide a stable, high quality output generation. While a optimization technique, we also have a technique where you can change your hyperparameters at every step instead of in the code, but we've also used it in the UI as well, as I'll show you in the results pictures. So the problem and the core difficulty is that sketches provide very little visual information. So GAN-based methods can be unstable while, sorry, is my audio, is it breaking?
No, we can hear you.
All right. Yeah. So as I was saying, the core difficulty is that sketches provide very little visual information. So GAN-based methods can be unstable, while different models depend heavily on the noise schedule. Choosing the beta and value manually is unreliable, which motivated us to use an automated optimization strategy, which is the wheel-based optimization. So the literature review. So previous work can be grouped into three categories. So the first is image translation methods using Pix2Pix or CycleGAN. Second is latent representation using variational autoencoders. Third is using diffusion models and latent diffusion models, which provide improve the image quality and stability. But as using the veil optimization has also been shown to be effective for tuning difficult hyperparameters. However, the existing sketch-to-face approaches rarely combine latent diffusion and swarm-based optimization in a single framework, and that is the gap our work addresses. So this is our system architecture. As you can see, we'll give a sketch which goes through a pre-processing. Then we send it to a variational autoencoder, which compresses it into a 128 into 128 size, which converts it into a latent space vector. And then we send it through a DDPM model and a veil optimization technique. You can see how a veil optimization technique. We send it to a variational
Your voice
decoder,
is
and then
breaking a lot in between.
Sorry. Is it audible now?
Yes.
All right. So lastly, we send it to a variational autoencoder decoder. So which then generates a face, image, and gradient interface. So our implementation details. We train the entire pipeline in Kaggle environment using PyTorch and NVIDIA P100 GPU. We have trained over 2 lakh 2,599 images using taken the images, converted them into sketches, and then we have used it using then we have a residual auto variational auto encoder which has around 10 epochs. We've used the Adam optimization technique, and then we've used the DDPM, which denoises over 1,000 scheduled time steps. Also built a gradient, then they can instantly, maybe within 5 minutes, see a generated face. So as you can see, this is our UI. We've used a sketch input. So in our input sketch, we can either upload a sketch or we can draw it, and then we can see a generated face. This is again why. So our results, as you can see, we've achieved an SSIM value of 0.85 and a PSNR number of 28.3, which is a 9% improvement in SSIM and a 3.2 decibel improvement in PSNR over the variational autoencoder plus DDPM baseline. So compared to the pix-to-pix, CycleGAN, plain DDPM, and standardized latent diffusion models, our approach produced the highest structural similarity. The trade-off is speed, which is a full 1,000-step diffusion, which gives the best quality. It requires about 25 seconds per image, while fewer steps are faster but slightly red quality. So our conclusion, to conclude, we proposed a swarm optimized latent diffusion framework that combines a residual VAE with a latent DDPM and an veil optimization for sketch-to-face generation. The method achieved strong quantitative performance and outperformed several GAN-based and diffusion-based baselines on Celeb A. A current limitation is the sketch is not directly injected into the denoising process. Few we want to concentrate on the cross-attention-based sketch conditioning or a faster-based DDIM or a DPM solver sampling. And also we want to work on the speed in which it generates an image. For now, it takes us about 5 minutes because of the number of layers, but we want to achieve it through a faster, in a faster time possible. Overall, our results suggest that combining probabilistic generative model with swarm-based optimization techniques is a promising direction for sketch-based face synthesis. These are the references that we've used, and that's it. Thank you.
Thank you so much. Do we have any questions?
Yes. Which swarm optimization algorithm did you use here? And why you're using that?
We've used veil-based optimization. So we have different swarm optimization techniques like bee, wolf, humpback whale, and different structures. But while we were implementing it, we found better results with veil-based optimization. We've gone with bee, wolf, and whale. Out of all of these, we've had better results with veil-based optimization technique. So we've gone ahead with that.
Okay, and how your approach is, we can say, the improving upon the general GAN-based or standard latent diffusion-based methods for the face recognition or face synthesis?
All right, as previously mentioned,
Your voice is
metrics in which we evaluate, the metrics which we use like SSIM, PSNR, or any other similarity indexes is better with while using a veil-based optimization along with the probabilistic generative model. There was an improvement in the metrics by either 10% in PSNR and a 3.2 decibel variation from the previous methods, which while GAN and DDPM only had a difference of around 1.5. By using optimization technique, there was a 3.2 decibel improvement. So that is how we have seen that this is a model. And it also gives out better image structure because it takes through textures or color, something like hair or any skin texture better.
Hello, Sirali, can we move ahead?
Yes, yes. Next, we have Shirij Brahmecha with the paper title Threat Sentry, an adaptive framework for detecting and defending against adversarial attacks in machine learning models. Dear presenter, you can start
Yeah,
presenting.
can you hear me?
Yes, sir.
Yeah. Jay, could you start the presentation? Good afternoon, everyone. My name is Shitesh Brahmecha, and along with my co-authors, that is Neeraj Bharadwaj, Jay Kumar Gore, and Professor Sarita Rathod, we are going to discuss. I'm going to present my research paper on Threat Sentry, that is an adaptive framework for detecting and defending against adversarial attacks. So in today's presentation, we will discuss the motivation behind our work, the proposed system, its features, implementation, and the experimental results. Jay, could you go to the next slide? Yeah. So, motivation problem statement. So, the motivation for threat sentry stems from the pervasive integration of AI into critical applications, that is like healthcare diagnostics, cybersecurity, to autonomous systems like self-driving cars. So, as AI offers immense benefits in its deployment in these mission critical sectors introduces a significant vulnerability gap. The small interceptable perturbation known as adversarial attacks can easily fool these state-of-art CNNs and transformers, leading to severe consequences such as machine failure, safety risks. So existing tools often lack real-time monitoring and authenticated logging, making reproducible evaluation and proactive defense challenging. So you can see here the vulnerability gaps. So let's move objectives. So our main objectives were the unified framework. So, which we in the unified framework, we would integrate the adversarial simulation, vulnerability assessment, and adaptive framework into a single cohesive architecture. And our one of the more important research was the real-time detection, which is not present in already existing frameworks. So, we would propose a proactive monitoring through confidence analysis, gradient sensitivity, and distribution shift detection. Also, the framework is fully implemented. Secondly, we propose the real-time detection mechanisms, which is currently part of our research roadmap. Thirdly, we have implemented an adaptive defense module, so users can upload their model and check how are their models can defend against these adversarial images. Lastly, we have also added an automated reporting, that is a user who has analyzed or done assessment on his own model. He can get a PDF report or a JSON file report of how vulnerable his model is, how he can make changes to the model to get defense against these. Next slide. So this is the proposed framework. So this slide illustrates the modular architecture of a proposed system thread sentry. So the first is it comprises of three core components. The first is the simulation engine, which we have fully implemented. Here you can evaluate the model robustness against comprehensive suite of adversarial attacks. So the main three comprehensive attacks are FGSM, PGD, and deep fool attacks. So FGSM attack is basically the fast gradient assign method. So imagine so in FGSM, what happens is we add a tiny edit or tiny kind of noise to an image that the humans can't see, but the AI model can get completely fooled. The similar are a PGD and deep fool. PGD is it is post projected gradient descent. So what it does is it is a stronger version of the HSM because it increases the perturbation through multiple iterations. And the next is the defool. Defool is basically how little changes are required before the model makes the wrong prediction. So basically, defool is used to entirely make the model predict wrong things. Next slide. So this is our system architecture. So as you can see, a user, so we have created a website which is hosted on Vercel. So it consists of clerk authentication for user authentication. It is deployed on Vercel and the UI layer. So in the backend layer, we have used Flask API, which assesses the threads plus the adversarial attacks and creates the results of PDF report. So for the user, we have added two model sources, that is the Hugging Face model hub. So if any user has fine-tuned or made a model and uploaded on Hugging Face, he can directly use the model name and get fetch it from its API for threat analysis. And the another option we have kept is customer user model, that is custom user model. So he can upload his .pt or bth file and then analyze the threats. Also for storage, we have kept two different. One is the model metadata and history. So right now we have kept it in JSON storage, and also the attack image stored in a folder. Next. So these three are the main which we are focused right now: the FGSM, PGD, and default attack. So as I explained, FGSM create method generates adversarial samples using using single step perturbation based on loss function. PGD performs iterative updates, so it is an advanced version of FGSM. And default, it is minimal perturbation required to cross model decision boundaries iteratively. Next slide. So the research methodology detection engine. So in this, we have researched how we can implement the real-time detection engine. So these three are that we have found: the confidence-based detection. So it analyzes the model output probabilities. It lowers the confidence scores often. Lower the confidence score often indicate the adversarial manipulation or out of distribution samples. So if the confidence score is very low, it can detect that the image has been noised. The gradient sensitivity analysis monitors input gradients. Adversarial noise typically triggers unusually high gradient magnitudes compared to clean inputs. The third is the distribution shift detection. So it measures the divergence between training and live data. So it checks if there is a lot of distribution between the image noise. So divergence identifies abnormal statistical shifts in input streams. Yeah. So the adaptive defense and recommendations. So adversarial training. So this is the adaptive defense that we have implemented. It incorporating perturbated samples directly into training pipeline to enhance model resilience. Recommendation engine. So after the PDF is generated, it recommends the dynamic generation of actionable mitigation strategies based on the attack type and success rate. So we have researched on advanced denoising. So we have researched that we can propose a pre-processing layer and gradient regulation for smooth decision surfaces. So here we can add a different this for denoising the image. So the system implementation and setup. So these are the experimental evaluations. We have done 35 assessment of different models and for three different types of attacks. We have done this using 122 different images. So we have also added custom model support. The core technology stack, as we have discussed earlier, we have React for frontend, Flask and REST API for backend, PyTorch and Hugging Face as our model transformer usage, the clerk JWT authentication for user-based access. So we have the RABC. Next slide. So these are the results that we have found. So attack-wise performance summary. So these are the different attacks. These are the runs. So these are the original accuracy which the model have. These are the adversarial accuracy that basically after adversarial images are passed on to the models. This is the drop that is that is done. So the attack rate is shown. So the average success rate and the mean accuracy drop is shown over here. Over here, the negative accuracy drop is due to some images which are not properly able to like be detected by the model. So that's why it shows a negative accuracy drop. Next. So the cross model comparison. There are different types of models. That is the statistics. So vision transformer demonstrated improved robustness against FGSM perturbation compared to standard CNN. CNN susceptibility. So like ResNet and FSNet showed high accuracy degradation under iterative attacks. So we found out that the paired t-test result, it shows a significance at the level of 0.052, 3.30 it showed the value, and the mean attack success rate was 71%. Next. So these are the comparison with existing frameworks. So ART is a well-known adversarial, that is the framework. So it is a partial real-time detection. Defense it is yes, but real-time logging it does not have a proper real-time logging. Feature squeezing it does not have a proper real-time detection, nor does it have a proper defense mechanism, and nor does it have a proper real-time logging. It only shows how much the success rate is there. Defense distillation also, partial defense and real-time log is not there. So what we have proposed is we can provide all three in a single cohesive framework. Next slide. So conclusion and future roadmap. So short-term goals we have is extended attack coverage. So instead of only three, we want to integrate square attack, trade evaluation, and ensemble auto attack methods. We also want to provide a multi-model support. Expanding vulnerability assessment to text, BRT, GPT, audio, and video models. Also, DevOps integration, we can add automated security testing pipelines using Docker for CI/CD production. Also, in long term, we have decided that we can also research and add explainable AI so that the users can understand that if we are really or actually being able to explain why and how it is analyzing the model attacks. Also, we can add more robustness and also quantum resistant AI. So, develop post-quantum defensive measures for long-term model security. Thank you. Open to any questions. These are the key references from which we took our understanding of the adversary attacks and how can we add more to it.
What makes your framework adaptive? Which feature you are, that what I want to ask, and how does it respond to what we say, the evolving attack strategies?
So right now, like we have only 3 attacks. So in future, what we can do is we can add more attacks to make it adaptive. Like we can make a agent for that, so that it will be able to adapt to a different. If there is a new kind of attack, it will try to see if there is any new perturbation or if there is any. So we will make a benchmark using by training other attacks, and we'll see if there is any irregularities in the benchmark, so that it can check for any different type of attack that will come.
Okay. Okay. And how does this threat sentry balance the attack detection accuracy with computational overhead?
Right now, for balancing, what we have done is so for as it requires high computational resource. So what we can do is we can divide it in servers so that while any kind of attack or assessment is done, it does not hallucinate or it does not break the algorithm. So yeah.
Okay. Okay. Thank you.
Thank you.
Thank you so much. Now, we have Abhinav Verma with the paper title YOLO Fast VIT, a robust two-stage hybrid framework for apple leaf disease detection and classification. Dear presenter, you may start presenting. Dear presenter, are you present in the meeting?
Hello,
Yes, sir.
ma'am, am I audible?
Yes, sir.
Yes, ma'am. Oh, sorry. There was a small minor problem, so I'll start the presentation now. Hello, good afternoon, everyone. My name is Abhinav Verma, and my topic for this research is YOLO Fast VIT, a two-stage hybrid framework for apple disease leaf classification. So it is a two-stage hybrid. I'll start with the introduction. Apples are one of the most widely cultivated fruits crops globally, with annual production of 94 million tons and more. Cultivation is significantly affected by diseases such as scale, rot, rust, etc., which reduces yield and fruit quality. The motivation for this research was to build a fast, accurate classifier to disease to detect the disease early in the stages for disease management, and to find edge-friendly work in source-limited field environments. And it was also created so that it could improve generalization across environmental and image variability. The problem statement is that current AI models are not trained on field images; they are rather trained on lab images, which are not very good which are not very reliable for apple leaf disease classification. Well, the challenges are the background variability in the background. There are different background lighting and etc. And here are the literature main key literature reviews snapshots that I have used in my research. And research gaps are that there are lack of real world testing. Most models trained on lab datasets, as I've told before, limited generalization of diverse orchards. There is also most AI models do not classify properly where the symptoms are very close to each other, like black rot and scab. They are almost very similar, but they are very different in tackling the disease. So the objective is to maintain a high accuracy on real dataset, lightweight model, real-time deployment, which will help the farmers to maintain their crops much efficiently. So this is the proposed model, which has two stages. One which will detect the leaf, and the other will classify the leaf into which disease it is. And the algorithm starts by stage one starts with detection of by using YOLO V8, which extracts multiple scale features, generate bounding boxes, and store detection leaf regions. After that, the crop images are resized, normalized, and other augmentations are performed. After that, the augmented images goes to the classifier, which is our fast vision transformer, which extract local features and gives the output to us. The dataset that I have used is an open dataset from Kaggle, which has three or four classes: health, apple scab, and rust and black rot. Performance matrices and accuracy curves, recall F1 scores are used on these diverse field test sets. Deployment: the target is to deploy a mobile target device and edge platform for real-time orchard monitoring. So the pipeline works like this: the leaf locate the, so the there is a leaf detector which locates the leaf and draw boundaries and cut it from the rest of the background. Second, the data set is prepared again, and the third is to classify the disease, and the evaluation happens. So it is like this: automatic localization of crops, as you can see in the picture, background noises and focuses classifier on apple leafy regions. This improves the signal to noise and standardize input to fast VIT. YOLO V8 for real-time time localization was used because it was because it has much faster convergence rate during training. Efficient transformer classifier locates local features and global leaf features with an effective hybrid architecture. Abstract log, which is very efficient for fast inference on crop leaves and combines convolution locality with transformer context. So the training configurations are the data split was like 60 for training, 20 for validation, and 20 for testing. The atomizer the use was AdamW with learning rates, scheduling, and grading clipping. Augmentation extensive augmentation across mixed labs and orchard images are used, and epoxy validations for use for training the model. So these are the training dynamics that I have observed, and here is the quantitative results, which has shown 99% accuracy on training, 92.42 on validation, and 91.82 on test accuracy. And this is the comparison with other models. And as you can see, the fast YOLO VIT plus half fast vision fast VIT has performed much better than other models. And so in conclusion, it is a very noble two-stage framework. which combines YOLO V8 for leaf detection and fast vision for disease classification. It has shown the model achieved 99.42 validation accuracy and 91.82 test accuracy, demonstrating strong performance across both laboratory and real-world database. The integration of object detection and hybrid vision transformer architecture improves the reliability of automated apple leaf diseases monitoring. So it enables scale precision algorithm monitoring and can extend to other crops. Thank you.
Thank you so much. Do we have any questions?
Yes. So which data set you used here for training and evaluation, and how many apple leaf diseases classes are you have included?
Ma'am, it was an Opal data set there in Kaggle, which was a Kaggle. I've used data set. It's a mixed data set, which was combination of Kaggle and from Plant Village, and some one and so that's it, ma'am. And the data set that I have used, it has 10,000 images.
Okay, and you have used here two-stage approach, right?
Yes, ma'am.
What advantage this two-stage approach provide or offer over an end-to-end detection and classification model?
Sorry, ma'am.
What advantage this two-stage approach provide over the end-to-end detection and classification model?
Ma'am, it has anchor-free it is an anchor-free architecture which simplifies training and improves localization. Good small object detection uses for leaves for different sizes, and such as robust and complex backgrounds such as orchards with branches and varying lighting, and it is easy deployment using Ultralytics framework.
Okay, thank you.
Thank you so much. With that, we are done with our presentations for today. I would sincerely like to thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will go live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. And I would also like to thank our session chair, Professor Archana. Thank you so much for chairing this session. A token of appreciation to the chair on behalf of Team ICT4SD 2026 and Global Knowledge Research Foundation and partners. Ma'am, before we end this session today, do you have any words you would like to share with us?
Yes. So thank you to all the presenters for sharing your innovative research. The today's session covered a wide spectrum of the different topics like AI-driven cybersecurity and optimization to computer vision, healthcare applications, and intelligent systems, which is basically reflecting the interdisciplinary nature of the current research, we can say. I also like to appreciate the efforts of organizing committee, reviewers, and all the participants for making this session successful. So I congratulate all the authors and wish you the very best for your future research. So thank you all.
Thank you so much for your valuable presence, ma'am. Now I would like everyone to switch on their cameras for a virtual snapshot. Thank you all so much. Stay safe and take care.